I'm now 3 decades into my professional journey as a climatologist, and while my focus has been Greenland and the Arctic, by teaching introductory and graduate level climatology courses at universities for more than 10 years, I'm in a good position to talk about global climate issues in ways that the news media often doesn't. So I'm rolling out a series of videos detailing in as plain language as possible what's behind the biggest issues in climate today. I decided to start with this year's record-shattering global temperatures, for which I'll describe here the 5 most important factors that I see at play, starting with the most well-known. So let's get into it. The atmospheric window that allows Earth's heat radiation to escape to space, it's narrowing from gaseous pressure broadening of various absorption bands in the atmosphere's absorption spectrum. Now in 2023, the planetary energy imbalance from enhanced greenhouse effect hit an all-time high of plus 1.97 watts over each square meter of Earth's surface. Now imagine a light bulb over each square meter of Earth's surface radiating downward with nearly 2 watts of energy. Multiply that by Earth's surface area of 510 million square kilometers, and you get an annual energy flux that could satisfy the current US electricity demand annually for 350 years. Anyway, the relatively steady increase in greenhouse gases alone cannot fully explain the jump in 2023 temperatures. So what else is at play? The record-shattering air temperatures this June and July of 2023 arguably has most to do with the oceans. Ocean heating from the enhanced greenhouse effect currently accounts for 91% of the heating in the climate system. Atmospheric heating accounts for just 1% of the total global heating. That's because the heat capacity of air is 4 times smaller than water, and oceans cover more than 7/10 of our planet's surface. Land warming and ice melt constitute the residual 8% of where the excess heat energy is fluxing. The global ocean heat content has been increasing since the middle of the 20th century, equivalent in recent years with 9,000 times the US annual electricity consumption. 9,000 times. Yet, again, that steady increase in ocean heat content can't on its own explain the record warm 2023 air and sea surface temperatures. What else is turning on? Part of the global heat wave is from the current El Niño that is forecast to last at least through the Northern Hemisphere winter of 2023-24. El Niños are the warm phase of one of the climate's greatest natural internal variations, called the El Niño Southern Oscillation. El Niños come and go in an irregular and difficult to predict 2 to 7 year cycle. During El Niño, the world's largest ocean in the Pacific ejects excess heat into the atmosphere. My sense is that the current El Niño is the main factor for the record warm 2023 air and sea surface temperatures. Yet there's more to the story that I think many of you have not yet heard. Now, what does the global heat wave have to do with shipping? Well, the International Maritime Organization, IMO, recognizing that ships' smokestacks emitted harmful sulfur dioxide, eventually sulfuric acid, which causes breathing and heart damage to people in port cities and no doubt is harmful to various other ecosystems at sea and on land, the IMO enacted in 2015 new regulations for low-sulfur ship fuel. While good for reducing sulfur pollution now by some 80%, that has allowed more sunlight to heat Earth's surface. You can imagine how this effect is especially important over the dark oceans absorbing more sunlight. The removal of the aerosol masking effect has produced a so-called termination shock that Leon Simons has been communicating. and there's yet more to the 2023 record high temperatures. A recent surge in total solar irradiance is worth consideration in the inventory of factors contributing to the 2023 record-shattering global air temperatures. For background, the Little Ice Age between roughly the years 1450 and 1900 is widely recognized to have been caused by low total solar irradiance and the cooling effect from a spate of powerful volcanic eruptions in the 19th century that, like ship fuel, temporarily and partially shrouds the surface from sunlight. Some key studies are linked below. Now, given that volcanic cooling of climate doesn't last for more than about 3 years, and the most recent major volcanic eruption was 32 years ago, we can exclude volcanic influence from the topic of so-called external climate forcings. Now, total solar irradiance, TSI, measured by satellites above Earth's atmosphere since 1979, have an average for June 2023 at an all-time high in the 40 years of measurements. High total solar irradiance this year is partly due to an earlier than expected increase in the natural sunspot cycle. More sunspots mean more sunlight is reaching our planet because the areas around the sunspots, called faculae, are much larger and brighter than the dark sunspots themselves. The recent uptick in total solar irradiance from a minimum in 2019 to a 40-plus year high has a maximum value of 2.1 more watts per square meter than back in 2019. In addition to the direct Earth surface heating effect of the recent increase in total solar irradiance, there are indirect climate warming effects involving mainly global ocean heat content that can eventually as much as double the direct TSI influence. According to the energy equilibrium equation for the Earth system, the recent TSI increase should have a direct global heating effect by 0.1 Celsius, rising to 0.2 Celsius once ocean equilibration can occur, a process that takes years. While there have been just 4 years which TSI has increased by 2 watts per square meter, the indirect effect is not fully at play, but is worth consideration and will only grow in the coming few years through 2026 or so, as TSI will be on the upswing as part of the sun's 11-year cycle. All of this is to say that the recent TSI increase can explain between 1/8 of the recent global warming from the direct sunlight absorption effect, or at most 1/4 of the 2023 warming if the indirect effect through ocean heating can eject some of that directly absorbed sunlight. Considering the low in atmospheric sulfur dioxide from no major recent volcanic eruptions, and the shipping reductions in sulfur dioxide emissions, the direct effect of the recent total solar irradiance increase can be about as strong as it can be. While I'm still waiting for the July 2023 TSI data to be released, total solar irradiance will in all likelihood be higher in July 2023 when most of the global heat records have occurred, so the story is worth revisiting soon. I have summarized how 5+ factors have contributed to the shocking increase in year 2023 global surface temperatures. These are an all-time high in greenhouse gas concentrations, increasing global ocean heat content, ejection of ocean heat content from the current El Niño, the warming effect of sulfur emissions reductions from an 8-year-old shipping fuel pollution regulation, and I might as well add how there have been no major recent volcanic eruptions. In other words, less sulfur aerosol shrouding the surface of our planet, and a recent stronger than expected total solar irradiance increase. My sense is that the current El Niño is the most important single factor, But nothing in nature occurs in isolation. The El Niño effect is riding up the escalator of ever-mounting greenhouse gas concentrations. The solar irradiance part of the story appears to be an important and underreported issue. That's why I so carefully but objectively include total solar irradiance, and not to undermine the fact that by far the largest factor in climate warming is human-driven greenhouse gas emissions. The sun is just one of a long list of factors that influence climate, with humans now having taken the wheel and become a force of nature at the planetary scale. I'll conclude by reminding us all to prepare for more and stronger heat-related damages, including more flash flooding, which is an indirect result of warming driving more moisture and heat into the atmosphere, all to only continue for the foreseeable future. To take the edge off of this dire future, let us support sustained, multi-age group, nonviolent movements to force policy and business to do what we know is necessary to reduce climate warming. We have to cut greenhouse gas emissions. We have to deploy carbon dioxide removal at scale. And my favorite approach there is tree planting, though tree planting also has its issues, like any environmental intervention. And to the defense of environmental intervention, before it was called climate change, it was called inadvertent climate influence. To what extent we make intentional climate interventions is a huge topic for another video, namely the many pitfalls of stratospheric aerosol injection.